Hello, we're gonna solve this question. Please read with me. A school wants to make a new playground by cleaning up an abandoned lot that is shaped like a rectangle. They give the job of planning the playground to a group of students. The students decide to use 1/4 of the playground for a basketball court and 3/8 of the playground for a soccer field. How much is left for the swings and play equipment? Awesome, guys. So we're gonna get started by completing the section of circle or underline. So what we're gonna do here, guys, we're gonna go sentence by sentence, and if we find a number, we're gonna try to understand what that number represents or what that number implies. So let's read the first question. A school wants to make a new playground by cleaning up an abandoned lot that is shaped like a rectangle. So I didn't find any numbers. I'm gonna keep going. They give the job of planning the playground to a group of students. Okay, again, identify numbers. The students decide to use 1/4 of the playground. Good. For a basketball court. So you see, I need to understand what this number is gonna represent, and I put all the information together in one color. Now I'm gonna keep reading, and then it says, and 3/8 of the playground. So this is another section of the playground that's gonna be used for the soccer field. How much is left for the swings and play equipment? And I'm gonna be using this cubes problem solving reference, and I did circle and underline. Now I'm gonna box the question, and many times, not all the times, but many times the question is very close to the question mark. So we're gonna box this right here. So please, we identify the question. Great. What we're gonna do next is do the elaborate section, and for elaborate, in this case, since I have fractions of a playground and they said that it looks like a rectangle, I choose to do fraction bars with rectangles. That's what I'm gonna draw to help me understand what's going on in this situation. Okay, so these fraction bars that I have on the left side are the ones that I'm gonna use to represent the playground. So this one here that has no sections at all is gonna be the original playground. This is gonna be the playground. And this is the whole with no sections. Now, if I look at my notes on what I highlighted, it says that 1/4 is being used for a basketball court. Which of the fraction bars that I have either on the top or on the bottom can represent 1/4? Yes, it's the one on the top. Awesome. So this one here will be 1/4. Can you see it, guys? This is 1/4 right there. And I'm gonna highlight that in green. It's just like I'm gonna bring down this piece from the top down here into the playground. So I can really see what the sections the students are assigning look like. And this section here looks like a 4 because I can see the 4s on top of it. And this one here, I said it's gonna be the basketball court. I'm gonna put that right here. This is gonna be the basketball court. Great. Okay, if I keep reading, then it says that 3/8 of the playground are gonna be for a soccer field. Great. So then I'm gonna look right here, and I'm gonna say, guess I'm not gonna use this 2 on the left side because that will be the 4 we already used for the basketball court. You see how these 2/8 look like 1/4? Great. So now we're gonna pick 3/8. So this is 1/8 so far, 2/8 so far, and 3/8. So all this is 3/8. Can you see that, guys? Great. So then I'm gonna transfer this section to the playground that I'm drawing. So right here I'm gonna say, okay, so this looks like 1/8, kind of. Then this one here looks like 2/8, and this one here looks like 3/8. Can you see that, guys? Great. So then I'm gonna shade in All this is those 3/8, and these 3/8 are representing what? Yes, the soccer field. The soccer field. I'm gonna look at the question, and the question is, how much is left for the swings and play equipment? Can you see what's the section that is left? Exactly, this is what is left. And if I look at the sections that I have down here, you see guys, it looks like this is what is left. This section looks the same as this one. So really, what section is left? Is 3/8. And I'm gonna make a cloud around this 3/8, and I'm gonna say this is my answer. So I can find my answer without doing really math operations, but only by looking at a picture and understanding what's going on. Great, so I did the section of elaborate right here. I don't really need to do solve for this question because I already figured my answer. Anyway, guys, stay there. I'm gonna show you 2 different ways on where you can solve this question if you wanna be doing math operations. So that's what we're gonna do next. The first strategy that I'm gonna use is I'm gonna use some flashcards that have decimal numbers, and I'm gonna use those decimal numbers. Can you see these 2 flashcards on the left side? Great. So the story says that he used 1/4 for the basketball court. I'm gonna put that in green because that's the color I use for the basketball court. You see here, this is green. So 1/4 means 0.25 was used for, yes, for the basketball court. Great. And for the playground, it says that they use 3/8. So if in this story they said that, okay, if my flashcard says that 1/8 is 0.125, what would it be 3/8? So if I have 1/8 is 0.125, can you see it here? What if I have 2? I will have to multiply this number by 2, great. But here they say they have 3, so I'm gonna multiply this by what number? By 3, great. And that will be like having 3 shaded sections here. It will be like doing this. 1, 2, and 3 out of the 8 sections right here. Okay, so can you help me to multiply? 3 times 5, 15. 5 and we carry 1. 3 times 2, 6. Plus 1, 7. 3 times 1, 3. 3 times 0, 0. Now let's look for decimals in each factor. This one has 1, 2, 3. This one has none. Total is 3 decimals. So from right to left, we move 1, 2, 3. There we go. So 3/8 will be the same as, exactly, 0.375 thousandths. Great. That's 3/8. Awesome. Now I'm gonna solve my question in here by, I'm gonna say, okay, if I have the basketball court and the playground together, I'm gonna use the color so you can follow me. 0.25 is for what, guys? Yes, the basketball court. Great. And then I'm gonna add this plus the number for the soccer field. The soccer field, remember, in decimal is this one right here. This is the soccer field. Great. So this is gonna be 0.375. Great. Empty spaces, we always fill them in with zeros. And now we can add. Please add with me. 5 plus 0, 5. 5 plus 7, 12. 2 and we carry 1. 1 plus 2, 3 plus 3, 6. Bring down the decimal point because with adding, we do that when adding and subtracting only. And then this is a 0. So this is a space of the section they use for the basketball court that we have in green and the soccer field that we have in orange. So this is together the soccer field plus the basketball court. Okay, so now if we look at this rectangle that we have on the left side, remember the question is just how much is left. And this section left will be everything in this rectangle, but not this green section and this orange section. So we're gonna subtract the whole playground. It will be the number 1. Remember, this is the playground. This is the whole playground. And then I'm gonna subtract that. And I'm gonna take away from the whole playground the soccer field and the basketball court combined. Line up the decimal point first, and then the number will be 0.625. Then on top of this, I should have a 0. So now we're gonna subtract that. So here I'm gonna say 0 minus 5. I can't, this is too small. So we're gonna have to borrow. I can borrow from the 0. This 0 can borrow from this 0. This 0 can borrow from this 1. So we're gonna borrow 1 unit from here. This will become 0. The 1 we took comes here. The 0 goes up, and this is not a 0 anymore. See that? Now this one can borrow from the left side. It's not a 10 anymore. Will become a 9. The 1 from here goes here, and this 0 goes up. So it's not a 0 anymore. You see that? Now this one needs to borrow from here. So the 1 we borrow comes here. This is not a 10 anymore. Becomes a 9. And this 0 goes up. These are my new digits. 0.9910. And it represents the same amount. So let's do this, guys. 10 minus 5, 5. 9 minus 2, 7. 9 minus 6, 3. Decimal point, because we're subtracting, we bring it down. 0 minus 0, that's a 0. And you see how this number here, guys, is the same number. Then, oops, see this number right here. So 0.378, what is left is the same as 3/8. When I find an answer, I put that in a yellow cloud. Right there. So this number here and this number is the same thing. That is my answer. Great. So far we did it just by doing the picture. Would you like just to solve the question doing a picture and not doing all this math? Great, you can do that. Okay, so also we did it with decimal numbers. Awesome. So like we're gonna say this is method 1. Just with a pictorial representation. This one here, I'm gonna say this is method 2. And now I'm gonna do method 3. And at the end, you pick the one that you like the most. Knowing more is always better. So this is what I'm going to do. I'm going to continue, and I'm going to do it now with fractions. So what we're going to have to do is, I'm going to say the whole playground is what number? The number 1. That is correct. And I use the number 1 because you see how we're working with fractions all the time, but every time that we refer to a complete playground or the whole playground, that will be the number 1. Great. So the other thing that we need to find out, remember, is the soccer field plus the basketball court. And I'm going to do this. Again, I'm going to go with green for the the basketball court. And we said that number is 1/4. The other number that we have, we use the orange for the other one. We can use any number actually. and the other number is the soccer field. And the soccer field is 3/8. Now I want you to look at this fraction bar that we have on the left side. How many 8s do you see we can fit in this green section? So what I'm asking is, how many of these 8s will take me to complete this green? Can you see my orange arrows? And yes, 1/4 equals 2 8s. Awesome. I did it by looking at the picture. Can we do that numerically? Yes, of course. We have to apply the same factor in both numerator and denominator. How do I go from 4 to 8? Times 2. And if I did it on the denominator, I gotta do it on the numerator. And you see how it is working? 1 times 2, that's 2. Great. So 1/4, like you can see on this picture on the left side, it is the same as 2 8s. Now that we have the same denominator, I can add them. We can only add fractions when they have the same denominator. So then here, if I put these two together, that will be what, guys? That would be 5/8. Awesome. Now, since I'm looking with 8s here, I need to rewrite this fraction here with a denominator 8. And again, I'm going to be using this fraction bar that I have on the left side with 8s. You notice this one, guys, I have 1, 2, 3, 4, 5, 6, 7, 8. So this rectangle has 8 8s. So right here, I'm going to say that this 1/8 here, this 8/8 is the same as the 1/2 that I have on the left, like a 1. See? And now from these 8/8, I'm going to take away the basketball and the soccer field combined. So I'm going to subtract 5/8, the ones that I have on the bottom. If the denominator is the same, it stays the same. What is 8 minus 5? 3/8. And that will be the answer if I do my problem using fractions. And then you see that this answer also is the same as this answer. So yes, whatever way I did it, either with decimals, with fractions, or just with a picture, I know my right answer in this case is letter A. Awesome, guys, you got it. Thank you.